Hello and welcome to this channel. This is Engineer Samuel and welcoming you to this channel. So in this video we'll be looking at treating some past questions on logarithm that has to do with JAMB, WAEC, NECO exam. So we look just addressing some past question. So please just hook on, get your pen and your paper and follow us as we go along. This is actually going to be very beneficial to students who are preparing for JAMB, WAEC, SSCE, whether IGCSE exam or any local or international exam. So as we go along, just enjoy. But before we move on, I will please beg you that if you're not subscribed to this channel, you should go ahead and hit the subscribe button and also click on the like button as well, because you are actually going to enjoy this video, this tutorial. So let's go along. So we have this question: evaluate log 125 to base 0.4. Evaluate log 125 to base 0.4. This problem here is actually a change of base problem. So we're going to apply change of base in what we call change of base in logarithm. Looking at it the way it is, this log 125 to 0.2, there is no relationship between 125 and 0.5. It's not glaring, it doesn't show. But first of all, let us change this 0.2 to fraction. So that is the first thing we're going to do. So these are the options for the answer. We have A, B, C, D. So our answer must fall among one of these options. So like I said, we have 0.2. So to convert 0.2 to fraction, we divide by 1. Next, this is one decimal place. We also create one decimal place here. So that is going to be 0.2, then 1.0. Adding 0.0 doesn't increase this number. 1 and 1.0 are the same thing. Over here, divided by 1 doesn't change the number. 0.2 divided by 1 is still 0.2. So next, we have one decimal place here. We have one decimal place here. So one decimal place in the numerator and one decimal place in the denominator. So what do we do next is that we will eliminate the decimal. So over here we have 0.2, over here we have 10. We do away with decimal, we remove the decimal. So 0.2 is the same thing as 2. So we can write this as 2 directly. So at the end of the day, we'll take to the lowest term. Lowest term, 2 in 2 is what? 1. 2 in 10 is 5. So this is 1 over 5. So at the end of the day, 0.2 is equals to what? 1 over 5. 0.2 is equals to 1 over 5. So next is we'll go back to our original logarithm expression. So we go back and introduce, in place of 0.2 we put 1 over 5. So now we have log 125 to base 0.2 can be written as log 125 to base 1 over 5. Now in change of base, is there any connection between 125 and 1 over 5? 125 is the same thing as 5 times 5 times 5. 5 times 5 gives you 25. 25 times 5 gives you 125. So 125 is the same thing as 5 raised to power 3. Why 1 over 5 is the same thing as, let's do it here, 1 over 5 is the same thing as 5 raised to power 1. This is from the reciprocal rule in indices. 1 over 5 is the same thing as 5 raised to power minus 1. So we are going to replace 125 with 5 raised to power 3 and 1 over 5 with 5 raised to power minus 1. So we have that log the log of 125 to base 1 over 5 is the log of, for 125 we have 5 raised to power 3. For 1 over 5 we have 5 raised to power minus 1. So since they have a common base of 5, so we're going to apply change of base law of logarithm. So they have a common base of 5, so we're going to use that. So this can be written as log 5 raised to power 3 base 5 raised to power minus 1 can be written as log 5. This can be written as log 5 raised to power 3 base 5 all over log 5 raised to power minus 1 base 5. They both have base 5, so we're going to use base 5 as our change of base. Base 5 becomes, since they have base 5 will become our base in the numerator, base 5 will become the base in the denominator. So we take log of 5 raised to power 3 to base 5 and log of 5 raised to power minus 1 to the same base 5. So at the end of the day, what do we have? This is going to lead us to from the power. When you have a power in a log, when you take the number of log of a number and that number is expressed in the index form, you can take the index, the power behind the log. So we're going to take 3 behind the log, take minus 1 behind the log over here. So let's do that. This becomes, the 3 goes behind. We have log 5 base 5 all over here we have minus 1 log 5 base 5 as well. Now there is this law of logarithm that states that the log of a number to the same base is 1. The law states that the log of any number to the same base is 1. So the log of 5 to base 5 is 1. So if the log of 5 to base 5 is 1, this is going to become 3 times log of 5 to base 1 is 1 over minus 1 times log of 5 to base 1. Log of 5 to base 5 is still 1. 3 times 1 is what? 3. Minus 1 times 1, minus 1. So at the end of the day, 3 divided by minus 1 is minus 3. So our final answer is minus 3. So our answer here is D. So the final answer there is what? D. Okay. So we apply some concept. Change of base was what we applied to solve this question. First and foremost, we had to convert this 0.2 to fraction. And then we look whether there was any connection between, we got 1 over 5 there. Connection between 1 over 5 and 125. And there was a connection. 125 is 5 raised to power 3. While 1 over 5 is 5 raised to power minus 1 based on the reciprocal rule of indices. Okay, this is 1 over 5 raised to power 1. This is 5 is raised to power 1. So when you take it up, the power will become minus 1. This is the reciprocal law of indices. But in case you have any issue, there's any point where you have problem, just drop your questions in the comment section. So this is just the solution to this problem. So we are going to go ahead and solve another one. Okay. So we have another question we are going to look at quickly. So we are asked to evaluate log 9 over 4 to base 2 over 3. These are the options A, B, C, D. So let's go ahead and quickly solve this right now. So So having this right now, we have 2 over 3 to 9 over 4, log 9 over 4 to base 2 over 3. That is what we have over here. Okay, so now 9 over 4 now 9 over 4 can be written as 9 is 3 times 3, while 4 is 2 times 2. So this can be written as 3 raised to power 2 over 2 raised to power 2, which is the same thing as 3 over 2 all raised to power 2, and 2 over 3 is the same thing as 2 over 3 raised to power 1 raised to power 1. If we have 3 over 2 for the number we are taking the log. So if we want to express this one in terms of 3 over 2, what are we going to do? We can say this is the same thing as 3 over 2 raised to power minus 1. This is the same thing as 2 over 3 raised to power minus 1 is the same thing as 3 over 2 raised to power minus 1, using the reciprocal law of logarithm. So over here, 2 over 3 raised to power 1 is the same thing as 3 over 2 raised to power minus 1. When you reverse the order of the fraction, the power is going to change. If it was positive here, it's going to change to negative here. If it was negative here, it will change to positive here. So our log now, log 9 over 4 base 2 over 3 can now be written as log 9 over 4 is what? 3 over 2 raised to power 2 to base 2 over 3 right now. 2 over 3 is same thing as 2 over 3 raised to power 1 is same thing as 3 over 2 raised to power minus 1. So over to base 3 over 2 raised to power minus 1. So we have 3 over 2 over here. We have 3 over 2 over here. So we can actually apply change of base. We'll bring in change of base. So the here over here, this is 3 over 2 raised to power 2. The base here is 3 over 2. Over here, this is 3 over 2 raised to power minus 1. The base is still 3 over 2. So what we're going to use as our change of base is the number 3 over 2. So this is going to be written as, at the top, we have log 3 over 2 raised to power 2 base 3 over 2. Then below, we have log 3 over 2 raised to power minus 1, then base 3 over 2. Then, so we've actually used 3 over 2 to change our base. Okay, 3 over 2. So now, what do we do now? We take the power 3 over 2 raised to power 2. When you have such in a log, the power can go behind the log. So that is what we're going to do right now. The power goes behind the log. We have 2 log 3 over 2 to base 3 over 2. This is 3 over 2 base 3 over 2. And over here, the power 2 minus 1 here. The minus 1 power is going to go behind the log. We have minus 1, then log 3 over 2, 3 over 2. This is over. So log 3 over 2 base 3 over 2 is 1. Log 3 over 2 base 3 over 2 is 1 as well. So at the end of the day, 1 times 2 gives you 2. 1 times minus 1 gives you minus 1. So we end up with 2 over minus 1. 2 divided by minus 1 gives you what? Minus 2. So the answer is option D. So the answer there is minus 2. So this is another example using change of base formula, or change of base rule or law. So I believe this is clear. I'm going to solve one more example before I call it a day. So in this example, this is still a change of base problem. This is JAMB 2005 question number 23. So we have solved the equation log of 16 to base root 2 equals to x. Log of 16 to base root 2 equals to x. So our solution is going to be root 2 is the same thing as, is there any relationship between root 2 and 16? There is a relationship. We can express 16 in terms of base 2, and we can also express root 2 in terms of base 2. So root 2 is the same thing as 2 raised to power half, where the 2 is the base, and 16 is the same thing as 2 raised to power 4, where the base also is 2. 16 is what? 2 times 2 times 2 times 2. 4 2's multiply themselves, so that is why we have 2 raised to power 4. Another way of writing root 2 is 2 raised to power half. Base 2, base 2. So the change of base we are going to use here is what? Base 2. The change of base we are going to apply here is, so log 16 root 2 is going to be written as log 2 raised to power 4 2 raised to power half. So next, what do you call it? We're not going to apply change of base. So we deal with this side. That is going to be log 4 to base 2 all over. We deal with this side. This is going to be this is going to be log 2 raised to power 4 2 raised to power 4. Our change of base we are using is base 2, because both of them are in base 2. So base 2, then log 2 raised to power half to base 2 as well. So the next thing you do is that over here you bring the powers, the 4 behind the log. Over here you bring the half behind the log. So you have 4 log 2 base 2 to half log 2 base 2. So log 2 base 2 is 1. Log 2 base 2 is 1. 4 times 1 gives you 4. Over here, half times 1 gives you 1, because log 2 base 2 is 1. So that gives you 4 all over half, which can be simplified as, this is 4 is simply as 4 over 1 divided by half. So this is simply as 4 over 1 times, you now get the reciprocal of this. This is going to be 2 over 1. So you are dividing. When you're multiplying, it's going to be the reverse of whatever is in the denominator. We have half in the denominator. 4 over 1 being divided by half in the denominator. When you're multiplying now, the half will change to 2 over 1. 4 times 2 is what? 8. 8. 1 times 1 is 1. So this is final answer at the end of the day is 8. The answer there is 8. The answer there is 8. So we are going to solve one more example, example 4, before we call it a day. So in this question, this is a past JAMB question, 2003, question number 19. We have, if log m to base 25 is equals to r log m to base 5, calculate the value of r. These are the options for r. So let's solve. Solution is going to be, we have 25 and 5. We have m and n. So what do we do? How are we going to proceed to solve this? We know that 25 is the same thing as 5 raised to power 2. 5 is the same thing as 5 raised to power 5. So we're going to apply change of base method. And our change of base, we're going to use 5 as the base. The base we're going to use in applying our change of base. So over here, 25 is the same thing as 5 raised to power 2. While 5 is the same thing as 5 raised to power 1. So we're going to change this to 5 raised to power 1, change 25 to 5 raised to power 2. So we have log m to base 5 raised to power 2 is equals to r to log 5 raised to power 1 m. Next, we apply change of base. Our change of base is going to be 5. Since already we have base 5 here. We have base 5 here. So we're going to use base 5 as a change of base. So over here, this is going to be log m to the new base 5 all over log 5 raised to power 2 to the new base 5 equals to r log m to the new base 5 all over log 5 raised to power 1 to the new base 5. So over here, this becomes you have log m base 5, log m base 5. So log m base 5 can cancel log m base 5, so that you have 1 over here and 1 over here. They can cancel each other. Or let's even leave, they cancel each other. They are on the same side, numerator, numerator. So in maths, you can cancel what is on the same, on opposite side. This is on the left hand side, this is on the right hand side, but they are both in the numerator. So this can cancel this. Or even if we cross multiply, this one will come under here and cancel the one above. So this cancels this. Next, we bring this one, log 5 raised to power 1 base 5. We bring it up here. And we now have log 5 raised to power 1 base 5 all over log 5 raised to power 2 base 5 equals to r is still remaining. So log 5 raised to power 1 base 5, log 5 raised to power 2 base 5. The powers that the 5 is carrying here can go behind the log. The power that this 5 is carrying can go behind the log. So this can then be written as, we have log 1 log 5 base 5 all over, the 2 goes behind, 2 log 5 base 5. Log 5 base 5 is 1. Log 5 base 5 is 1. So at the end of the day, what we have there is half. R is equals to half, which is option C. So we've actually solved 4 examples on change of base. Change of base. So like I said, that this can go a long way. If you're writing SSCE, GCE, WAEC, NECO, JAMB, or any international exam that involves logarithm, that this can actually help you. So with this, we actually come to the end of our lesson for today. So please, you do yourself a whole world of good. I believe you had your pen and paper. You can go over it once again. And if you're not subscribed to this channel, please go ahead and hit the subscribe button and hit the like button as well. And you can drop your comments. If you enjoyed the video, drop your comment that you enjoyed it. If there are ways you feel we can actually help you, you can also drop your comment as well. If there's a point during the solution process that you had issues, also you can drop it in the comment section. And in case you need a one-on-one lesson, or there's any other you want to communicate with me further, my WhatsApp number is just there. That is +234 8038295185. So I'm available if you need one-on-one lesson, whether online or offline, depending on your location. So thank you so much for joining us, and join us in the next class. Bye.